Hello everybody and welcome to the latest video for Siemens Electrical Products. I'm Chris Ward and today I intend to take you through the 3RM1 motor starters, where you might use one and what the main selling points are of utilising a device of this capability. So where could you use the 3RM1 motor starters? As you can see here, you have a 3RM1 motor starter. That has yellow tabs on it, which would tell me that it's a fail-safe version of the 3RM1. There are two versions, there's a standard and a fail-safe version, but ultimately they both have integrated contactor and overload facility. So in all of our 3RM1 offerings, there's a contactor and an overload capability. Where might you use one? What type of applications? So you can use them for resistive loads or you can use them for inductive loads. So the resistive loads might be lighting circuits, they might be heat lamps, they could be conveyor systems, small fans, logistical systems, applications of that nature. Now, when you're using a 3RM1 motor starter, a typical configuration of a protection device or a motor starter sequence would have short circuit protection, a switching device, and then the overload. So with the 3RM1, as I mentioned earlier, you have a contactor and an overload integrated into the unit, but then you would also need a form of short circuit protection. And you can do that by means of two methods. You can either use a motor starter protector, which you can see there, or you can use a fused base. So you can integrate the fuse protection or the motor starter protector into a 3RV application to give you the full protection of the motor system. Another key element to the 3RM1 motor starters is that you can actually integrate them directly into a safety function. So a safety function typically consists of three subsystems. You've got detection, evaluation, and reaction. Whereas if you are taking the 3RM1 motor starter failsafe version and you're putting it in with, say, for example, a 3SK1 advanced, or like in this picture, it's in it with a 3SK2, you're actually integrating two of the subsystems together to make it a more simplified safety function. So you're integrating the evaluation stage and you're also integrating the reaction stage into the one system. So the main selling points and benefits and features which we're going to drill down into are: you get a long service life, you get integrated safety, it's more economical, it's simple to connect, and it's more compact. Now, this just gives you an idea, and it applies to all of the hybrid technology. So just to give you an idea as to how hybrid technology actually works, and the hybrid technology is integrated into the 3RM1s. So hybrid, the reason why they call it hybrid is because it integrates electronic switching, which you can see here with the two thyristors, and mechanical switching, which you can see here with the mechanical bypass, into the one device. So it takes the advantages of electronic switching and mechanical switching and comprises them into the one device. And the way that it does that is during the startup, when you switch the motor on, the voltage and the current runs through these anti-paralleled resistors, which means that there's less wear and tear placed on this mechanical contact. So that mechanical contact will then last for a bit longer, and it also reduces the implications of arcing. So once the motor is actually up to full speed, then what happens is this mechanical bypass will then latch in, so that these thyristors are then not running at a rate of knots. Because if you have semiconductors running constantly, you get a lot of heat and you get a lot of power loss. So the idea is that once you're up to full speed, the mechanical bypass then latches in, and then these remain unoperational until we initiate a stop. Once we initiate a stop, this mechanical bypass then unlatches, and then these thyristors start to operate again, placing less wear and tear on the mechanical contacts. And as a result of using that type of startup This is typically done on 2-phase. With the 3RM1, it is only done on 2 of the phases, but we have soft starters where it's done on 3-phase control on the hybrid devices. Now, what are the advantages of doing it like that? Well, if you use that type of technology, a contactor would last for up to 3 million operations, whereas if you use a hybrid device, it lasts up to 30 million operations. So you get an increased service life of your product, so it lasts for a lot longer. Now, if you were comparing it to a VSD or a variable speed drive, when you're switching a motor at full speed and at 100% of its operational capacity, you will make a heat and power loss saving when you compare it to a drive. But that's only under the circumstances of using it at fixed speed and at 100% of its operational capacity. Also, when you compare the hybrid devices to contactors and VSDs, you also make a space saving inside of the control cabinet. So the next highlight which we like to talk about is the safety. So the integrated safety. So when you're using the 3RM1 motor starters, you can use them in applications up to SIL 3, which is the highest level of safety for a system which you can achieve. Now you can integrate them directly into a safety function if you use a 3SK2 or a 3SK1, or you can also achieve a safety related shutdown through a fail-safe CPU if you wish to as well. Now, it's also really quick and really easy to be able to wire these devices up, and it really simplifies the circuit. So it's simple handling, there's less wiring, it's easier to project plan, and it saves on time and it saves on money. So this next slide just gives you a bit of an overview of the product variants. So it's more economical to use because there's fewer options, so there's less products to keep in store. There's only 4 options which you can have. There's direct online starter, reverser, and then you can have the same options in failsafe. Now that can be up to failsafe SIL 3, and the overload which is integrated into both of those units can be used in an ATEX environment. So there's 3 current ranges, and that they go up to 3 kilowatts. 2 control voltages, you can either select 24 volt DC or you can select 110 to 230 volt AC or 110 volt DC. You can have a combination of screw or push-in terminals, or you can just go screw or push-in terminal, whichever way you would like to go with that. So we say it's really simple and it's really easy to be able to set up. And the reason behind that is pictured on this next slide, and it encapsulates it really well. So when you use a 3RM1, it reduces the amount of components in the circuit. It's as simple as that. There's a reduction in components. So if you use a 3RM1 and you use a standard DOL, you only need to use the one device, whereas if you was to use a conventional setup for a DOL, then you'd need a contactor and an overload. If you was to go for the SIL 3 DOL, it would use 2 contactors and an overload. If you was to go with a reverser, you would need 2 contactors and an overload. So as you can see, there's fewer components needed. Also, as a result of those fewer components needed, there's less connection cables needed, which means there's a reduced time in the installation. If you use this bus bar comb, which sits along the bottom of the motor starter chain, which can achieve up to 25 amps, you'll make a reduction in the mains wiring circuit, so you'll save time on the installation process. You can also use these device connectors which slot into the back of the motor starter, and you can daisy chain these up, which also provides a wiring reduction inside of your control circuit as well. And another cool feature of this device is that it's really quick and it's really easy to set up. So the only thing that you have to justify on the motor starter is what rating the motor is, and then from that you will then be fully operational with the motor starter. And the reason why you need to set that potentiometer with the current is so it aligns with the overload which is integrated into the unit. So it's really quick and easy to set up. All you have to do is check the nameplate of the motor, see what the current rated is, and then put that and adjust that potentiometer to suit. And the last part is that the device is extremely compact. As you can see here, the device is 22.5 millimeters in width and it's 100 millimeters. Now the beauty of this product is that no matter which one of these devices that you select, whether it's DOL, reverser, or the failsafe versions of those devices, it remains in this really compact enclosure. So it remains at 22.5 millimeters to 100 millimeters. So as you can see, the comparable differentiator between each of them is directly underneath. So you make a significant saving as you go up the scale. So when you compare that to a standard starter, 45 millimeters by 140, it's literally half the size in width. When you're looking at it in terms of 90 millimeters compared to 22.5 millimeters, or where you've got here, you've got with the failsafe reverser, you've got 90 millimeters compared to 22.5 millimeters, and by 200 millimeters in width. You know, you're making an extreme saving there in terms of the compactness of the device and the functionality that you get within it. So I hope you found this presentation of the benefits and features useful. If anybody has any questions, please feel free to get in contact with me, and I hope you found the video useful, and stay tuned for more. Thanks very much.